Got into a little bit of trouble here with this video that went up on the May the 1st, 2022, has 1,600 views. That should not have been public. That was a problem-solving video I sent to the electrical inspector and Alpha ESS. And why are people watching my channel? Well, that's a lot of views. That should be unlisted, because that was mid-commissioning. There was a problem with the battery, it wouldn't turn on. Now I have to make it unlisted because some smart ass is talking about problems. You see, he's got to prove he's a better installer than me because he has to compensate for a small penis. So there you go. So I have to respond. Well, first of all, yes, the instructions are ambiguous. This dotted line here, do I put wires in there or not? Because there's other models out there who use the same kilowatt hour meter, such as this Solis. Here's the PDF for it. This Solis inverter, the RHI series, it only has 2 wires in there. So if we go back to my photos of my original visit there, before the problem occurred, as you can see, I've only got 2 wires in there because of the dotted line on the instructions. Turns out when I went back, yeah, sure, I had to fix that. Yeah, sure, where is it? Here it is. As you can see, went back out there, put the other 2 wires in, very, very small terminals. And I didn't want to put an extra circuit breaker in there. It was a tight squeeze just for running some voltage wires to the kilowatt hour meter. So I actually ran 4 mil in there. And they all had to go back to the 25 amp circuit breaker. It was just too compact in here. Now, what else? He said something about the earthing. And here we go. I haven't put any earth wires on here. Why are there 2 earth wires? It's because that's for putting extra battery packs adjacent to this one. You have to link it with a battery earth wire as well as the 2 extra battery cables. But between the battery and the inverter, yeah, I could put an earth wire on there, but I'm only going to bolt it to one of these mounting bolts anyway, because the inverter itself doesn't have these. So these are more like battery to battery earthing terminals, and I tested it. It was earth, and the inspector seemed to be happy about that. So well, let's look what the instructions say. No external earthing required. After the protective earth line of the AC cables has been grounded, the whole inverter, including the case, will be grounded. So the whole case is going to be grounded. That's what it says there. And the inspector was happy with that. Here it says, though, later on that there's an earthing point that has to, of all of the batteries. So it's kind of like hinting that we're talking about linking batteries together. So when Alpha ESS finally looked at that video, as well as 1,600 other people, God. Anyway, it turns out that Alpha ESS said they have a circuit breaker behind this blank plate. And I asked them that on the phone on day 1. I said, there used to be a circuit breaker there. There's no circuit breaker there. You wouldn't put a blank plate over a circuit breaker, would you? Well, they did. And that was the problem. And I didn't want to go pulling apart battery covers, voiding warranties potentially, so it could have been fixed on the day. It took them 4 or 5 days before they realised it. Anyway, got done, and I had to label it myself. Look, I made my own label. Main battery isolator. I put it on there just so people knew that there was an isolator behind there, or circuit breaker. That's the 10.1. I've only had trouble with the 10.1 kilowatt hour battery. If you're going to go Alpha ESS, let me tell you right now, go 13.3. It's 100% discharge. This is 90% discharge. So overall, it turns out to be cheaper, as in cents per watt hour, so to speak. So it's a much better deal. It's just, I think it's the next generation. It's just better designed. Let's have a look at it. So when I'm not subcontracting, I get to choose what I want to put in. Put this in for a customer. It's the 13.3 kilowatt hour battery by Alpha ESS. It was much better. Everything went right. There was no commissioning issues. Just went like just slightly different arrangement there. They've got the circuit breaker here. I don't know if you can link it with other batteries. Seems to only have 2 terminals here. It's got the same 2 earths up there though. Where's the whole picture of this job? Just, it grew and grew. This is a retro system I put in many years ago with a GCL battery. Here's the new one, and I had to be creative with the kilowatt hour meters so they wouldn't be competing against each other. What the hell did I do? I can't even remember. So I've got the new one there on the consumer's mains, and that comes in here through this main switch here, right? And it seems to go in and out of the Alpha ESS here with this 2-pole thing. and off to some circuits. I think I've got this. Well, let's go and have a look at the cover on it. Here we go. Yeah, Alpha ESS backup circuits. The other one didn't have backup circuits. Look, I've had to fit in a 10 amp breaker there for the kilowatt hour meter, which got installed somewhere else. The Alpha ESS kilowatt hour meter. These are grid connect. So when you had, yeah, that's right. This kilowatt hour meter here is grid side, and the Alpha ESS has its own backup circuits. So, and this kilowatt hour meter here from this retro system, it can't recognize any other system. So the answer was to, I have to rethink this, damn it. That's it, I can see a wire going around the back and up over the top before it goes into these grid connect side here, yeah. So this one here is downstream from this kilowatt hour meter here, so it doesn't get confused. This kilowatt hour meter, the retro one from 2017, will get confused if it's perhaps exporting back to the grid more power than the inverter it's connected to, and it'll get confused and go into fault mode. So that's downstream, independent, and this one can recognize that there's possibly another grid connect inverter there. So that one went upstream from this one and also separate. It's in parallel. As you can see, this red wire goes across to the Alpha ESS, and this one here does whatever it likes, because being downstream, I'm repeating myself, but it's good to reinforce it. Downstream, it's not affected by any power export, import, what have you, from the other system upstream from it on the grid side. So this, as far as this kilowatt hours meter is concerned, this could be in the next door neighbour's house. I think they want an EV charger now. Yeah, they want an EV charger. So yeah, those batteries are still working fine. Still pretty good capacity since 2017. These batteries last a long time. I thoroughly recommended the 13.3. So much better than the 10.1 in Alpha ESS. It's worth the extra money. This is my house. It already had a 30 kilowatt system on there, and I had to get a battery rebate. Batteries under the house. You're allowed to put it under the house, but you had to fire seal everywhere under the floor and whatnot. And there's a battery isolator. Now this is the Solis inverter here. And don't know where the earth is. I actually have a big ass earth going, 16 mil. 50 mil cables going to the battery. So that must be, again, a photo before the end of the job. There's the battery. Big 15.4 kilowatt hour BYD battery. That one there is bulletproof as hell. That one can go off grid. I've got to find that earth wire, because that's separate from the... looks like I've added it here. There it is. So that's when you add an earth wire in this situation. Where's the zoom button, please? Is that zoomed? Oh no, it's fully zoomed. There you go. Zoom, zoom, zoom. I even put it under silicon just for good measure. 16 mil because it was 50 mil cables going off there. And, you know, I'm a solar installer. I end up with a bunch of panels, a pallet or two or what have you. And next thing you know, I've got to do something with them. The BYD had an app. Is this after I put the second battery in? I got stuck with the second battery, so I put it in there. Let's have a look at that. So, since the date of manufacture, BYD will give you a warrant time to install it up to 12 months. As I said, since the date of manufacture, and it was getting up to 12 months. Sat in the garage for about 6 months, because funny enough, that 13.3 kilowatt hour Alpha ESS job was going to get one of these, but it was in the carport. I couldn't get an Alpha ESS because they were going like hotcakes last year, all the shipping problems, COVID issues and whatnot. So I ended up wanting to put this one in as a last resort, because you couldn't put it in the carport. It was just going to be horrible installation. Fortunately, the 13.3 came up with the Alpha ESS, slammed it against the wall, was out of the way, put a bollard. You may have seen a bollard there. Here's the two bollards which are required in a carport, so a car can't hit it. They told me I could recharge it. As long as it got recharged within 12 months, I could maintain that warranty, even if I installed it over 12 months beyond the date of manufacture. But I said, well, since I've got to put it in to charge it, I'll just leave it there. So now I've got 30.8 kilowatt hours of batteries. And these things, I bought them for a ridiculously low price of, I think it was 7,800 Aussie dollars, not US, bloody hell. Aussie dollars plus GST. Now they're like over 10,000 Aussie dollars because of, everything going up and whatnot. So at least I got a good price. As you can see, here's the cement sheet up on top. Bit of a serial number there. And I bought the cheapest inverter possible, the Solis multi-mode inverter, which can do the job in hybrid mode, not off-grid. Forget about it, can't run it off-grid, it'll blow up. But it does a great job as a hybrid connected inverter. I didn't go with the L3SS, of course, because it comes with its own battery. This one I could plug into the BYDs. It was matched to it. Very good. Has a data cable, the whole lot. As you can see, CAN over there, all good. The only trouble is I've got a big 30 kilowatt inverter there, and this is only on one phase, and it only seems to charge at 3.3 kilowatts. So I've got 10 kilowatts of panels, or should I say 1/3 of my export from my 30 kilowatt system is in one phase, which this is connected to, which you can only charge at 3.3 kilowatts. So in winter, these batteries at 30.8 kilowatt hours wouldn't even fill up. So to improve the situation, I can get a 3-phase kilowatt hour meter here and plug it into this thing, and it will charge up at maximum capacity, of course, because it'll be calculating the export across 3 phases and drawing from one phase to charge the battery, because in Australia the billing is the average of all the 3 phases. So you might as well take advantage of it, get a 3-phase kilowatt hour meter and plug it into the single phase Solis. Now the thing about this Solis inverter, they're not very good with the instructions, especially these ones, because they don't tell you that in backup mode, if the grid goes down, see how they've drawn the backup circuit separate from the grid circuits? They're all going back to the same switchboard. Well, you're not going to put a switchboard and rerun final sub-circuits to it. So the big problem here is if you've got a multiple earth neutral in the main switchboard, and this one decides to make a multiple earth neutral, which it does if the grid goes down and it goes into backup mode, it'll join the neutral to earth here in the inverter. So now you've got parallel earth and neutral path. So you've got to have a separate neutral bar in the main switchboard, and that solves that problem, so that your backup loads are connected to neutral via the inverter in normal function from the grid, and then in backup mode it makes its own MEN, and so here's his switchboard there. Got a grid connect here at the top, which is pretty much a main switch going off to another main switch, which the only circuit on the grid connect side goes off to the back shed, which also has 3-phase. But look here, we've got this main switch coming in. That's from the grid side. Another one next to it is from the backup side of the Solis inverter, and it goes through this double pole changeover switch, because the Solis also, if it ever shits itself, you won't have any all your backup circuits are going to be dead too. So you got to have a double pole changeover switch, so you can switch the neutral as well from the backup output from the Solis back to the main switchboard. Obviously, if I switch this to grid, the neutral to these backup circuits will be connected to the main neutral. So in backup mode, the neutral will be, this one coming out the top into these circuits, will be connected to the output from the Solis. So here's the main switchboard. There's the, I like 2-pole. I don't like turning off an inverter and then, you could have the backup supply still going, or you could have grid. You want to isolate. That to me is isolating the grid side and the backup side all in one. I like the 2-pole. Gee, I've got a lot of shit here. I'm going to put EV chargers on this house before I sell it. It's got so much power, it's ridiculous. But it's got the capacity to charge probably 2 EVs. And as you can see, only 2 wires in the kilowatt hour meter, because of the ambiguous configurations of this bloody thing. So commissioning can be a bitch. So that's the main switchboard right there. So I hope that's as clear as mud. So here's the clause for earthing for electrical generators in the Australian Standard 3000. says here, neutral and earth connection, or MEN, has to be at the main switchboard. So when the Solis makes an MEN, when there's no grid, it goes into backup mode. What does that make? The Solis inverter the main switchboard? I don't know. But anyway, you can't have your sub-circuits in backup mode connected to the main neutral, because then that neutral also has an MEN connection in the main switchboard. So look here, neutral and earth conductors shall not operate in parallel, which is what had happened if you don't separate the two neutrals. Which is why in this subboard we've got a neutral bar up here and another one down here, and this 2-pole changeover switch. So back where we started, the alpha ESS doesn't join the neutral and earth together. With the grid goes off and it goes into backup mode. So where's the final determination? I can't say final solution. The final determination is here, which is everything's joined in the one neutral bar, nice and easy, easy peasy. There, as you can see, this is the arrangement for the alpha ESS, the way they organise this meter. It's got multiples of terminals being used for the voltage reference. Yeah, here I don't have the 2-pole switch. And the inspector wanted it like that, not me. He said, oh, you got to be able to switch them separately, blah, 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 whatever. Okay, so this one has a main switch here, grid side and off-grid side. I like to use a multi-core cable. As you can see, it's 3-phase multi-core, 3-phase neutral and earth, because then I can color code. See, backup neutral's blue. Black is grid neutral, because in Australia black is generally neutral. Red is generally active, 1-phase supply, so that becomes the grid side, and the white becomes the off-grid colour. I like to use multi-core, very, very simple. So back to this video, which caused my issues that had to be sent to Alpha ESS and the inspector for consideration. I'm going to make it unlisted now so I don't cop any shit from guys like this. Every time you get a job as a subcontractor, you're putting on a different bloody inverter, and everything's just, nothing's standardized. It's like back in the early phone days where everybody had a different phone charger. Anyway, this is going to unlisted and being replaced by this video. I should point out that if you do separate the neutral bars for your backup circuits on the alpha ESS, you get a different problem. If I pull that link out there, because all the alpha ESS backup circuits are here, then you will find that your earth is like 120 volts to active and 120 volts to neutral. So, because obviously the inverter is tapped halfway and grounded halfway. So that's a bit of an issue. So don't do that on the alpha ESS. Don't separate your neutral. Now I can say goodbye. Bye.